I will press like this first. Now look, the first thing it does is check whether it is correct or not. If it is correct, it will continue with the rest of the tests. It measures. So now it is injecting 1 ampere and measuring the voltage. After finishing that, what does it do now? It measures something. Line, magnetization curve. After finishing the magnetization curve, it measures, of course, the eddy losses and things like that in between. Then it will check the ratio. Okay, here it checks the ratio. Okay, and then it tells you, okay, what's your assessment? And is your assessment okay? Well, the engineer did something called demagnetization, which I'll show you in a bit. It did it automatically right before stopping its test. The idea is simply that the test is okay, meaning the test is finished. As for the assessment, okay, let's understand together what this assessment is. Let's take a look at the test results. Of course, this initial card is just entry data. It's input data only, all right? But let's start with resistance. Here is the resistance. It injected, telling you that it injected 1 ampere DC at 1.03. It found the voltage to be 7.899 volts. This means that the resistance is 7.666 ohms at 18 degrees. When it converts to 9.397, the resistance here, either you have it and thus you see the test result, or you check the manual from the transformer manufacturer to see what it is. If you don't have this or that because you're working in an old station and you don't have it, all you need to do is record this result and refer to it every time after that. Great, so the first thing is the resistance. I need the resistance not at the ambient. Now, let's move on to the excitation. It tells me that your voltage is 900 volts, and here's the excitation current. All right, before I continue with the rest, I want to see the graph. I press here for the excitation graph, and it shows me the shape of my graph. And here's the point right after which it enters the saturation phase. Of course, if you want to move the cursor forward or backward, you can do that. As you can see, the first part is almost linear. All right, okay. He is now working according to the state and the pilot, or the name means both. All right, and stay with me. I haven't finished here yet. If CT isn't 6000 A primary, it sees 1.0021A, not 0.99 or 1A secondary. Ratio error, 0.213%. For 5B20, ratio error must be up to 1% at rated primary current. The ratio error is 0.213%, and we said that for the 5B20. Its ratio error should not exceed 1% at the rated primary current, but should not exceed 5%, up to 20 times the current. If the current exceeds 100% of the rate of current, up to 20 times the rate of current, the ratio error should not exceed 5%. Okay, so what about the polarity? Well, the polarity is fine for me. Here, there is something called assessment. This assessment is not an engineer evaluating the results. It evaluates the results without you having to discuss them. The first thing it mentioned is the class, which is okay in terms of the error, and so on. And of course, you go down like this by the hour, and you will find the accuracy limit factor, and you will find what it means. It is all about a class and a group, all right, engineers? So the assessment involves looking at the class, the error, the angle, and something called the accuracy limit factor. These are called assessments. What does assessment mean, engineer? Now, this resistance is something measured. So it is the value of the resistance, that's number one. The excitation and voltage and such things are tested to ensure the voltage and stability until it reaches saturation. So this is something measured. The ratio is something measured, right? But the idea of the error here is that it compares this error to the 1% you mentioned to ensure what? To ensure that the standard is what it is supposed to be. It doesn't exceed what? What is it supposed to be? It is supposed that they do not exceed 1% for its current transformer. Since the device itself complies with the IEC standard, what did it do? It checked the commutator error to ensure it does not exceed the limit. So in the assessment, it indicated that it is okay. You have two errors, this one and the composite error, which are both listed together, and it confirmed that everything is fine. Regarding the polarity, you have the phase shift between the primary and secondary, which is measured in radians, not degrees. It is 0.5, and it is supposed to be 0. So 0.5 means it is okay, indicating that it is subtractive polarity. Therefore, in the assessment, it also stated that the angle is okay. All right, and the accuracy metering factor, this is what we talked about. We mentioned the accuracy metering factor based on this equation. As you explained to us, it calculated this at 900 volts and 1 ampere with an impedance of 9 ohms, and you told it to get 30 volt amperes. So when it calculated the K factor, it found it to be greater than approximately 29.77. This means it is greater than 20, but not excessively greater, which is why before this, what did he tell you? He said, okay, and you also confirmed it. Everything is correct like this. Very good. But look here with me at something called results with operated burden. I want to see what happens if I'm not reaching 30 volt amperes. What will happen to you here? If you press on the precise, it gives you 16.88, which is less than 20. Here, you need to pay attention. 1688 is less than 20, so here you need to pay attention. So now you are the one who told him that the operated burden for you is 60 volt ampere. You told him that it is 60 volt ampere, meaning your normal burden is 30 volt ampere. If you told him you want the operated burden to be 60 volt ampere, you will find the accuracy factor is less than what? Less than 20. Here, he won't tell you the assessment failed because he always compares based on the rated burden, not the operated burden. So, regarding the rated CT, yours is correct. Now you will connect it to different loads. Be aware that saturation will occur earlier for you before 20 times the current.